Welcome back, my mathematically minded minions. Well, tonight we're going to look at the effects of changing the h in the graph of f of x equals a times the quantity x minus h squared. So if we look at this one, we notice here from talking about the forms of this one, this is in part of the vertex form. So when we look at this one, we're going to alter the h. We're going to change that h value in. We've already looked at what happens when we change the a. Just a quick reminder. Remember, we looked at the a when we made the a number bigger than 1, because we know in our parent function it starts as 1. We start with a 1 here out in front of it. But any number that's bigger than 1, doesn't matter whether it's positive or negative, any number that's bigger than 1 is going to make it get narrower. Okay, the graph is going to squeeze in. It's going to be compressed vertically. It's going to be compressed. It's going to be squashed in, or it's going to be stretched out vertically, whichever way you want to look at it. It's become steeper. And when we look at numbers between 0 and 1, if the a is some number between 0 and 1, that's when it gets wider. It gets so much steeper depending on that. So tonight we're going to change that h. So let's go ahead and start with our parent function. We're going to look at f of x equals x minus 0 squared. Well, what's x minus 0? It's just x. So this is the same thing as looking at f of x equals x squared. It's our parent function. We're just looking at it as 0. So if we start here with negative 2, if we've got negative 2 minus 0 squared, well, negative 2 minus 0 is just negative 2. Negative 2 squared is 4. That's what it is. But what if we look at x as negative 1? Well, negative 1 minus 0, it's still negative 1. Negative 1 squared is simply 1. Well, what if it's 0? 0 minus 0, well, it's still 0. 0 squared is simply 0. What about 1? Well, 1 minus 0, that's 0. That's 1. 1 squared is simply 1. Well, what if x is 2? What's 2 minus 0? Well, that's just 2. And 2 squared is 4. Notice here, same as before, we have our symmetry. We can see where our vertex is right here. So our vertex is here at 0, 0. Looking at our point 0, 0, there's where our vertex is. We've got symmetry at 1, 1, and at negative 1, 1, and then at 2, 4, and at negative 2, 4. So, and then at 3, 9, and negative 3, 9. So this is what our parent function looks like. This is where we start off. This is the base of everything. So we're going to look tonight at changing that h inside and see what happens. Okay, so first of all, let's take a look at a different function. Let's look at a function where we alter this one. And let's start with f of x equals x plus 1 squared. Okay, so we changed that h. We changed that number. Instead of a 0 here, we increased it. It's a 1 now. So let's go ahead and let's look at this function. We've got some values here, some numbers. Let's go ahead and plug these in. Let's see what happens, and then we will go from here. So if x is 2, so now we've got 2 plus 1. Well, 2 plus 1, well, that's 3. 3 squared is 9. So at 2, we're at 9. Okay, what about 1? So if x is 1, well, we've got 1 plus 1. Well, that's 2. 2 squared, well, we're at 4 here. Okay, well, what about 0? If x is 0, well, 0 plus 1 now, well, that's 1. And 1 squared is 1. Okay, so looking at these. What about negative 1 now? Well, negative 1 plus 1, well, that's 0. And 0 squared is 0. What about negative 2? Well, negative 2 plus 1, that's negative 1. Negative 1 squared is 1. So if we turn around and we take a look, hey, we can start to see some symmetry right here. We see symmetry at these 2 points. It's starting to change. So let's go ahead and plug in these values and see. So at 2, we're at 9. 1, 2, we're at 9. 1, 2, 3, 4, 5, 6, 7. Ooh, 1, 2, 3, 4, 6, 7, 8, 9. Hey, look, it's right beside where we were on the other one. Okay. And at 1, we're at 4. So at 1, we're at 4. Okay, that's quite interesting. Notice that these two are just the same y value, just one away on the x. Okay, so let's look. Well, at 0, we're at 1. Huh, here again, just one away. Now, at negative 1, we're at 0. Okay, that's quite interesting. What about at negative 2? Well, we're back up here at 1. So notice now right here, we're 1 to the left. So we can see what's happening here. Notice this. We can see where the vertex is. Notice that our vertex before in our parent function would, our vertex was simply right over here for that one. But now that we've looked at this one, notice where our lowest point, our vertex is scooted over here. We moved our vertex. Our vertex came over here one space. So what's happened? All of our values are just one away. Well, so if we look at this, well, I wonder what would happen if we plugged in -3 in here. Well, let's look. Well, what if we do -3 plus 1? -3 plus 1. Well, that's -2. -2 squared is simply 4. So 1, 2, -3, we're back up here at 4. Ooh, what about -4? What if we did that? Well, -4 plus 1, that's -3. -3 squared, hey, that's back at 9. So if we go there, notice here, we still have symmetry now. But notice what's happened to our graph. It hasn't gotten any wider. We can see that. Nothing's changed. All that's happened is we shifted to the left. So we've simply shifted it to the left. So this +1 over here, this +1, notice if we add a number, it shifted it to the left. So if we had done a +2 in here, instead of shifting one place to the left, I bet it would shifted 2. And if that was your hypothesis, you would be correct. So any number that's in here, if it's a positive number, this plus number, it's moving it to the left. So let's take a look. Where's our vertex at now? Well, our vertex in this case is at -1, 0. There's our vertex. Where's our axis of symmetry? Well, I've already established this. We know it's an x equals line. And what is x? What is our x value? It's x equals -1. We know that because it has to go through our vertex here. And what's the direction? It still opens up. We still have a minimum. So changing that h in there to a positive number, all it's done is it's shifted the graph to the left. So with that hypothesis in mind, here we go. Let's take a look at another one now. So for this one, let's go ahead and let's try f of x equals, well, we did x plus 1, so let's go with x minus 1 squared. So go ahead and hit pause on this video. We've got the two other graphs. We've looked at the parent function and the f of x equals x plus 1. Let's go ahead and hit pause. Go ahead and fill out the table of values for yourself. See what you get here in these numbers, and then we'll come back in just a second and we'll talk about it. All right, well, welcome back. So hopefully you've had a chance to fill in your table. Let me just go ahead and punch in my numbers real quick. If x is 2, so now we've got 2 minus 1. 2 minus 1, well, 2 take away 1 is 1. 1 squared is 1. Okay, so we're going to be at the point 2, 1. What if x is 1? Well, 1 minus 1. 1 minus 1 is 0. 0 squared is, well, we're at 0. Okay, well, what if x is 0? 0 minus 1, well, that's -1. -1 squared, well, that's just a 1. What about -1? Well, -1 minus 1, that's -2. -2 squared is 4. And if it's -2, well, -2 minus 1 is -3. -3 squared is 9. So if we look at this, well, we can see we've got symmetry right there, those two symmetric points. So let's go ahead and plug in our values and see what we get. So when x is 2, 1, 2, we're at 1. When x is 1, we're at 0. When x is at 0, we're back at 1. Get my pen to go. When x is -1, we're up here at 4. When x is -2, we're up here at 9. So we can see this one, we can see the bends. So obviously here, if we were to plug in 3, we can go ahead and predict what we're going to be. I bet we're going to be at 4 right here, since we're keeping with the same thing. So let's see. 3 minus 1, well, that's 2. 2 squared is 4, and we would be correct. 1, 2, 3, we're at 4. Well, go ahead and, so what do you think the next one's going to be? What about 1, 2, 3? What about 4? 4, you would be correct. 4, we're back here at 9. Because we have symmetry, we can see this point here, this point. We've got symmetry on both sides. We will always have symmetry with a quadratic. So as long as we can find it. So here we go. Here's our graph of this one. Notice the only thing that's happened here is from our parent function, from this one that's graphed in black. Notice that the one we did, x plus 1, the one in blue, was shifted. The vertex was moved to the left. All the points were shifted one space to the left on the x value. Now that we did x minus 1, notice the vertex has shifted 1 to the right from the parent function. So we can look here, and where our vertex is now at 1, 0, at 1, 0. Axis of symmetry now. Axis of symmetry, a line that goes through it. It's right over here. There's a line that divides it. It's always an x equals, and it's x equals 1. Direction didn't change the direction, still opens up, still have a minimum value. So as we look at these, we can see that that has shifted it over. So let's go ahead and let's kind of wrap this up. Let's come up with a conclusion. So if we look at a function f of x equals a times x minus h squared. If we look at this one, if we had to summarize and explain what happens, got a hypothesis. If h is greater than 0, if h is a number bigger than 0, in other words, if h is a positive number, looking at that right there, so if this number is, so if we wind up with x minus 4, so we've got a positive 4, say, in here. So that's going to shift it to the right, okay? Now what if h is a number less than 0? So what happens if we have a negative number, x minus -2 or something? Well, that's going to shift it to the left. I guess an easier way of looking at this is if we look at this one, if we have an x minus h in here, anytime we've got a minus h, this minus says we're moving it to the right. If we wind up with something like an x plus h, well, that means our h has to be a negative value. That's the only way we get a positive number in here, considering this is our base function. So if we have an x plus h, that's going to the left. A good rule here is if we look inside our parentheses, it's always inside the parentheses is going to move us the opposite direction. So normally you would think, hey, positive numbers on the axis, positive numbers are to the right. Well, because it's inside the parentheses, it's going to instead move it to the left. Normally we think of negative numbers, but inside of parentheses, it's going to shift us to the right. So hope this clarifies it for you. If you need to go back and hit rewind on this, watch it again. If not, we're going to work some examples in class, and we will see you then.